Hello, my name is Maria from mathmammoth.com. In this lesson, we're going to learn about combining like terms. But first, let's review what is a term. A term in math is an expression that consists of numbers and or variables that are multiplied. For example, 2 times 8. So this is a term. It's an expression that has multiplication and then numbers and or variables. Or you might have 4 times x. That's a term. Or you might have t to the third times 0.6. This whole thing is a term because it is multiplication, variables that are multiplied, t times t times t, it's multiplication there, and then 0.6. And here's one more. Let's look at y divided by 4. This is a term. You might say, but that's not multiplication. But yes, it is, because division can be written as a multiplication by a fraction. This is actually the same as 1/4 times y. However, here's an expression that is not a term. There's a subtraction there. This is actually an expression that consists of two terms. S is a term and 2 is a term, and they are separated by subtraction. Then a constant. Constant is easy. It's a term that is just a number, such as 18 or 0.34 or 7/6. All of those are constant terms. Coefficient is a number by which a variable is multiplied, or a variable part. So for example, 4 times s cubed. 4 is the coefficient. Or you could have x times y times z times 7. So then in this case, 7 is the coefficient. It's the actual number by which the variable part is multiplied. And then like terms are terms that have the same variable part. So for example, 6x, and then we could have negative 8x. These have the same variable part, x here, x here. Or we could have 0.6 s squared, and then we could have s squared. Those two are terms that are like terms, the same variable part. Note though that these two are not like terms, 7y and 8y squared. The variable part is not the same. I know the letter is the same, y and y, but this here is actually y times y. It's not the same variable part as just plain y. And this is important because we cannot combine these. If we have like terms, we can combine them or add them, but if they are not like terms, we cannot do that. Now let's look at an example of combining like terms in an expression. So essentially we're going to simplify it. Here's an expression that has many like terms. This one, this one, this one, this one. All of them have the same variable part, just x. So we can combine them or add them together. And for that purpose, when we have here minus 7x, this is actually a subtraction, but you can think of it as plus negative 7x if you want to think of adding all of these. Or if in your mind it's easier to subtract, that's fine too. Essentially, we will take the coefficients of these terms and add and subtract them. This one here, what is its coefficient? It just says minus x. The coefficient is negative 1. So if we gather the coefficients, we get negative 1, then plus 8, and minus 7, either subtract 7 or add negative 7, and then plus 20. So here we would have negative 1 and negative 7, negative 8, plus 8, that's 0. Then so that just leaves plus 20. So all in all, we get 20x from all of those. And then we have these constant terms. There's 8, subtract 7 or add negative 7, either way, and this one here. So 8 minus 7 is 1, minus 3 is minus 2 or negative 2, like that. So that's how this whole expression now simplifies to 20x minus 2. Some more. Look at those yourself and try to do the work yourself. Simplify them. In this one, we can combine 2x and minus 8x. We can also combine 5 and minus 10, the constant terms. So 2x minus 8x gives us minus 6x, right? Then 5 minus 10 is subtract 5 or minus 5. This one here, 2s squared and 8s, they are not like terms. We cannot combine them. The variable parts are different. S squared is not the same as s, so we do nothing there. However, we can combine the constant terms, 12 and minus 7. So this one simplifies to 2s squared minus 8s and then plus 5. Notice that we write it in this order. We put the constant term last, and then as far as the variable terms, we write first the variable term with the highest exponent. What about here? How do we simplify these two expressions? Try them yourself first. Here's 2s squared times s times negative 3s times minus 7. Okay, notice that this is multiplication. There's no addition or subtraction. So we are not combining terms that are separated by addition and subtraction. This is one term by itself. We can still simplify it because we can do some of these multiplications here. We can multiply 2 times negative 3 times negative 7. That gives a positive answer. There's 6 times 7, 42. And then there's s squared times s times s. So that becomes s to the 4th. In this other, yes, we can simplify. We can combine like terms. 2a and then 4/5 of a. Those are like terms. It's a fraction. It will help if we write this 2 as a fraction also. 2 equals 10/5. And now 10/5 minus 4/5. We can calculate here with the coefficients. That becomes 6/5 a. And then 1 minus 4 is minus 3. Did you get the same? I hope so. Let's look briefly at some shortcuts. If we have two negatives, such as 2 minus negative 7, it simplifies to a plus. You already know that, right? But it also works if we have variables. If we have 2x minus x, this minus still simplifies to a single plus. So this is 2x plus x. And we can combine the like terms and get 3x. And then minus plus, if it's addition, subtraction, in other words, this is subtraction, subtracting a positive item here. You don't often see this, but if you have 2x minus plus x, that's what I mean, then this would be the same as 2x minus x. It simplifies to a single minus sign. It's like this simplifies to a single plus sign. And 2x minus x simplifies to x only. Plus minus simplifies to a single minus. For example, 2x plus minus x. It's the same as writing 2x minus x. And that would simplify to an x. Then lastly, the plus, you don't often see this, but it would simplify to a single plus if you have 2x plus x. That's the same as 2x plus x, which is 3x. Alright, so here's an exercise about all that. Try it on your own first. To simplify it, we have plus here and plus minus. Let's just simplify those and use the shortcuts. 2x, this one becomes single plus. Plus minus becomes a single minus. Minus becomes a single plus. And minus plus becomes a single minus. So what do we get? We can combine all these like terms. They all have x as a variable part, except the constant term 7. X minus x, nothing happens there, it's a 0. And here's 2x plus x, 3x minus 3x, leaves 0 also, so we're left with just 7. As one quick example, let's use what we have learned to solve this equation. 5.6 equals this expression, but in this side here, we can simplify. We can combine like terms. We have 3x, and this becomes a plus. 3x plus 2x, 5x minus x. So that's just 4x. And then 9 minus 1.6 becomes 7.4. And the other side is the same. Now what? I'll mark it here in the margin. We want to isolate x, or the term with x, so we subtract 7.4. We get negative 1.8 equals 4x. Next, divide by 4, so this still stays negative. If you divide by 2, you get 0.9, then take half of that, 0.45 equals x. Alright, we're all done with this lesson.